Our Earth supports a wide scope of diverse species, from the smallest of organisms to the tallest of trees. From using anything from lights to cars, we are constantly releasing copious amounts of carbon dioxide into the lower atmosphere. Our oceans act as carbon sinks. When this CO2 is absorbed into the sea, it reacts with the water molecules, or H2O, and forms carbonic acid. This carbonic acid breaks down into a hydrogen and bicarbonate ion. If the bicarbonate ion is formed, there are less carbonate ions available for organisms with a calcium carbonate exoskeleton to maintain or build their exterior. These extra hydrogen ions cause the ocean's pH to decrease, therefore causing the water to become more acidic. To add, when there are too many of these ions, not all of them are able to bond with water molecules and begin to break down existing calcium carbonate molecules, like in shells, corals, and some planktons. Our first experiment exhibits how water absorbs carbon dioxide. We displayed this by filling a jar with water and mixing it with the universal indicator, which gives a visual representation of the acidity of a liquid. We then placed another, smaller container inside of the jar, which contained half a teaspoon of bicarbonate of soda. After that, we put a small amount of vinegar on top of the bicarbonate of soda, which caused a chemical reaction to occur. This specific chemical reaction released carbon dioxide into the jar, which the water further absorbed. This made the water more acidic, which is clear by the way the universal indicator in the water is turning yellow. For our second experiment, we placed eggshells, which are made from calcium carbonate, into 3 different pH solutions. After 2 weeks, the eggshells in the more acidic solutions lost over 46% of their mass, compared to the other eggshells in the less acidic solutions, which lost less than 2% of their mass. To conclude, ocean acidification is a huge problem, and it is up to us to fix it.